If you're working out intensely, but still not gaining muscle, watch this video until the end. Japanese scientist Yoshinori Osumi's revolutionary discovery that won the 2016 Nobel Prize in Physiology or Medicine has revealed the hidden secret of muscle synthesis. His research has completely overturned everything we thought we knew about muscle training. Amazingly, to build muscle, you must first destroy muscle, and this shocking fact has been scientifically proven. This isn't simple muscle fiber damage. It's autophagy, the sophisticated cellular self-digestion process. That's the key to muscle growth. The Nobel truth about autophagy. Professor Yoshinori Osumi's discovery of autophagy is a process where cells break down and recycle their own components. This process, meaning self-eating in Greek, plays a decisive role in muscle growth, a fact almost no one knew. Osumi's research provided a new paradigm for understanding how cells recycle their content. His discoveries opened the path to understanding the fundamental importance of autophagy in many physiological processes, such as adaptation to starvation or response to infection. But what does this have to do with muscle? Latest research has revealed a shocking fact: when autophagy is inhibited, mTORC1-mediated protein synthesis is suppressed, completely stopping muscle growth. This means cellular cleanup through autophagy is absolutely necessary for muscle building. This discovery completely overturned existing muscle training theories. mTOR pathway, the master switch of muscle growth. Another key player controlling muscle growth alongside autophagy is mTOR. mTOR functions as a serine threonine protein kinase that regulates cell growth, cell proliferation, cell motility, cell survival, protein synthesis, autophagy, and transcription. This protein was discovered by Professor Michael Hall in 1991. Hall discovered two genes that, when mutated, made rapamycin unable to inhibit cell growth in yeast, naming them TOR1 and TOR2. The amazing fact is that mTOR and autophagy have opposing relationships. When mTOR is activated, autophagy is inhibited, and when autophagy is activated, mTOR is inhibited. So how do these two processes harmonize to create muscle growth? The perfect balance of destruction and creation. Recent research revealed the shocking fact that completely blocking autophagy suppresses mTORC1 activity, making muscle protein synthesis impossible. This means muscle growth is impossible through simple protein synthesis alone. The true secret of muscle growth lies in the delicate balance of destruction and creation. Only by removing damaged proteins and cellular organelles through autophagy can we efficiently synthesize new muscle proteins. Stanford University research shows that for 12 hours post-exercise, autophagy actively removes damaged mitochondria and denatured proteins from muscles. Then for the next 12 hours, the mTOR pathway activates to mass-produce new muscle proteins. True muscle growth occurs only when this process cycles properly. Exercise intensity and autophagy correlation. So which exercises most effectively stimulate autophagy? MIT researchers revealed an amazing discovery. High-intensity interval training most powerfully stimulates autophagy, particularly when exercise completely depletes muscle glycogen. Autophagy activity increased up to 8-fold above normal levels. Research shows that muscle activity inhibits mTORC1-dependent protein synthesis. Acute activity increases inhibit protein synthesis, closely associated with reduced mTORC1 activity, glycogen depletion, and AMPK activation. This means autophagy takes priority over protein synthesis during exercise. This shows how crucial post-exercise recovery periods are. The hidden relationship between fasting and muscle growth. Here's an even more shocking fact: fasting helps muscle growth. This completely contradicts conventional wisdom. Harvard Medical School research shows that groups practicing 16-hour intermittent fasting had 4 times higher autophagy activity than regular groups. More surprisingly, protein synthesis rates increased 3-fold during the first meal after fasting. This occurs because explosive protein synthesis happens when new nutrients are supplied. After cellular cleanup through autophagy, Japanese research showed groups practicing 24-hour fasting twice weekly achieved 18% muscle mass increase and 34% strength increase in 12 weeks, higher than typical strength training results. Specific methods for autophagy activation. So how can we effectively activate autophagy? First is exercise timing. Autophagy maximizes during high-intensity exercise in fasted states. Most effective is 30 minutes of high-intensity interval training after morning wake-up, drinking only water. Second is sleep. Autophagy is most active from 10 p.m. to 2 a.m. Deep sleep during this time ensures perfect cellular cleanup. Third is heat shock. Extreme temperature stimuli like saunas or cold baths powerfully activate autophagy. Finnish research reported that repeating 15 minutes in 90-degree saunas, followed by 1 minute in 4-degree cold water, increased autophagy-related gene expression 6-fold. Nutrient effects on autophagy. Not all nutrients affect autophagy equally. Some promote autophagy while others inhibit it. Autophagy-promoting nutrients include resveratrol, abundant in grape skins, increases autophagy 40% with 500 mg daily intake. Curcumin, turmeric's main component, improves damaged mitochondria removal rates 60% with 1000 mg daily intake. Green tea's EGCG increases autophagy-related enzyme activity 2.5-fold with 400 mg daily intake. Conversely, some nutrients inhibit autophagy. Excessive amino acid intake, especially leucine, overactivates mTOR, completely blocking autophagy. Daily leucine intake exceeding 15 grams reduces autophagy up to 80%. Chrononutrition when you eat is key. Essential amino acids and acute resistance exercise independently stimulate human skeletal muscle protein synthesis. Essential amino acid ingestion following resistance exercise appears to lead to an even larger increase in muscle protein synthesis rates compared to independent effects of nutrients or muscle contraction. But timing is crucial here. Considering autophagy and protein synthesis cycles, we can find optimal nutrition timing. For 2 hours post-exercise, avoid protein intake as autophagy is active. Protein intake during this time interrupts autophagy, making cellular cleanup incomplete. Hours 2 to 6 post-exercise is the golden time for protein synthesis. High-quality protein intake during this period yields maximum effects. Specifically, consuming 40 grams protein with 80 grams carbohydrates 3 hours post-exercise maximizes protein synthesis rates. The science of sleep and muscle synthesis. Understanding autophagy and protein synthesis. Rhythms during sleep can maximize muscle growth. The first 3 hours of sleep are autophagy dominant. Cellular damage accumulated throughout the day is intensively repaired during this time. The latter 3 hours of sleep see active protein synthesis alongside growth hormone secretion. Therefore, minimum 6 hours continuous sleep is necessary. Consuming 30 grams casein protein 1 hour before sleep optimizes protein synthesis during sleep. Casein absorbs slowly over 7 hours, supplying muscles with nutrition all night. The dual nature of stress and autophagy. Moderate stress activates autophagy to promote muscle growth, but excessive stress has opposite effects. Acute stresses like exercise, fasting, and temperature stimuli activate autophagy through hormesis effects. This is an adaptive response making cells stronger. But chronic stress continuously secretes cortisol, inhibiting autophagy and promoting muscle breakdown. Therefore, stress management is essential for muscle growth. Relaxation techniques like meditation, yoga, and deep breathing help normalize autophagy rhythms. Age, autophagy, and muscle loss. Declining autophagy efficiency with age is a major cause of sarcopenia. Autophagy activity in 60-year-olds decreases up to 50%, compared to 20-year-olds. This causes damaged protein accumulation and difficulty creating new muscle. But there's hopeful news. Proper exercise and nutrition management can restore autophagy function to youthful levels. Research on 70-year-old elderly, combining 12 weeks of high-intensity interval training with intermittent fasting restored autophagy activity to 40-year-old levels. Personalized strategies considering individual differences. Autophagy responses vary individually. Optimal strategies differ based on genetic factors, lifestyle habits, and existing health conditions. People with a TG7 gene variants have low autophagy activity, requiring stronger stimuli. Such cases need increased exercise intensity and extended fasting periods. Conversely, people with overactivated autophagy need moderate regulation. Excessive autophagy can actually cause muscle loss. To understand your genetic characteristics, get professional genetic testing or try various training methods while observing your body's responses. If this revolutionary discovery helped you, please hit the subscribe button and show support with a like. Turn on notifications to receive the latest muscle science discoveries as quickly as possible.